Hello everyone. Today we will explore how IBM watsonx.data, Lakehouse and IBM Bob are transforming fraud detection in credit card management. This is about turning risk into resilience, protecting customers while improving efficiency. When we are looking at the challenges, then we can see credit card fraud is rising globally and traditional rule-based systems are struggling to handle these frauds. Too many false positive, frustrate customers and waste analyst time. Fraudsters are evolving faster than legacy system can adopt. From the solution per se, we introduce watsonx.data lakehouse, which unifies all data sources into a single lakehouse for real-time analytics. And we deployed IBM Bob, a command center that integrates alerts, workflows, and AI-driven recommendation. Together, they create a modern fraud detection ecosystem. Outcome from these solutions are fraud losses reduced by 40% in the first year, customer trust improved thanks to fewer false alarm and faster resolution. Analysts now focus on genuine threats instead of chasing false leads. Next, we are scaling fraud detection into mobile banking. We are integrating external feeds like a dark web monitoring, and we are continuously evolving AI models to stay ahead of fraudster. This is the solution architecture what we have discussed in the previous slide. End user is going to interact with IBM Bob. IBM Bob is going to fetch a data from watsonx.data with the help of MCP server. Whatever the questions are in your mind, you can ask to IBM Bob in natural language and you can get an answer immediately from IBM Bob with the help of MCP server. Having said that, this will help you to build dashboard as well. Now moving to a demo. This is a IBM Bob UI where this is the first question I asked to IBM Bob to list down all the engines available on watsonx.data. So it is saying there are two engines, one is a Presto, other is a Spark. So let's check. So here if you look at this infrastructure manager, here you can see the two engines are available. One is a Spark, other is a Presto. Here you can see the multi-domain data is available in this multiple catalogs. Here you can see iceberg data is catalog, sample data is a catalog, and data is from the different domains just like products, finance, and even raw data is also available. And here you can get the multiple databases which are connected to the lakehouse. Now I would like to check how many catalogs are there. After asking a question, it is going to check for MCP server connectivity. It will execute. First time it was saying it was checking for the catalog. And now you can see it is going to execute a command. It will return a result. Now here you can see there are 6 catalogs. The names are iceberg data, sample data, JMX, system, TPCD and TPCH. Now I would like to check how many domains data is available in the lakehouse. Here you will get appropriate information based on the data analyzed with the help of AI. So you can see the list of the domains associated with the data present in the lakehouse. So if you notice, it is listing the schema, it is checking for individual catalogs, it will check the individual tables, and at the end you can see the result. the data associated with finance domain, sales domain, retail domain, even the benchmark data is also available, and DS benchmark domain data is also available within multiple schema. Now, coming back to our point that what percent of transactions are fraudulent, I would like to check that. So, what percentage of transactions are fraudulent versus non-fraudulent? So we will wait for this query to execute and see how much percentage of the transaction are fraudulent and how much are genuine transactions. So now if you look at the query, it first listed all the tables. Now it is trying to describe the table to understand the metadata of individual table, and it is going to execute a select query on top of it to get the result to identify the percentage of a transaction are fraudulent versus non-fraudulent. So if you are observing, we are not going to provide any kind of additional information to this Bob, so that it is itself it is fetching the information and creating a query. So now here you can see the result. Out of 10,000 transaction, 1.1% of the transaction are fraudulent, and 98.9% are non-fraudulent transaction. So if you wanted to see all the fraudulent transaction, so you can ask show all fraudulent transactions. So it is going to fetch all the record, whatever the queries pre-built by IBM Bob. It is going to leverage the same with the help of watsonx.data MCP server. So here it is executing. I am working on it. Always it is prompting a message. All 109 fraudulent transactions you can see on the screen. So now I got the information with respect to the 109 fraudulent transactions associated with the credit card. So I would like to see couple of the names. I would like to see fraudulent customers name. When you are asking that question again, it is revisiting lake house and building a query, again describing a table, because this time I'm asking for a customer information. So now we got the information with respect to the percentage of the transaction. Now the persona of the fraudulent activities or the fraudulent transactions. Now we'd like to build one dashboard. So now here you got the output for the fraudulent customer analytics. So based on that, now we would like to build a dashboard, the fraudulent transactions with credit card details. Create a dashboard which shows fraudulent transactions with customer details. Yes, now you can see the dashboard is created and it is going to open the HTML file. Open HTML file. Yes, approve. Here you can see the internal browser is open. Just I would like to see the same dashboard on the web page. Here you can see the fraud detection dashboard. Total fraudulent transactions are 20. Unique customers affected 17. Total fraud amount is 675.0 dollar, and average fraud value is $33,750. So here, if you notice, I have not provided a single information, and this dashboard is created by default by IBM Bob. Thank you.